health application is to keep the data honest all the way through the stack. So a few of us have created this pyramid. So yes, it does involve some component of blockchain, but it involves some tools in cryptography at the sensor level, hooking into our data stores, whether they're secure central ones or these new decentralized ones, governed by smart contracts, what we call utilities. And then my particular project is automating the verification of any science or the truthfulness of anything in a broad sense. So going back to our sensors, there is a fundamental weakness that nothing is secured directly from a sensor onto a blockchain today. There's always some human or some automated way which could be interfered with. But even worse, even if we tie that down, cryptographically speaking, the guys at Napier did a demo based on the electricity power going through the laptop, took my public key. So that's just by monitoring the electricity. And if it's a Bluetooth connection, they can intervene Wi-Fi and even microwaves. So the reason they do hack proactively at these technologies is because then they stand back and say, what can we do defensively to prevent them? So there's two schools of thought running on here. One, the people at Napier are working on, which is the whole notion of a zero knowledge proof. And the best way I like to describe that is saying, if you were wearing a pacemaker, probably even the ones today, but especially five years ago, there was no certainty anyone could hack the protocol. It was open, just like our Bluetooth today. But even worse, they couldn't certify that the software that was running on it was giving the amount of beats that they asserted that you should have. And again, even through a bug or through an attack, that can be manipulated at will. So the idea is you can put the zero knowledge proof in the clock. And all this the zero knowledge proof saying, it's like a heartbeat. It will complete the cycle of a clock. And if it does that, it can do a handshake to a blockchain. And over time, you can get this audit trail of what the capabilities of the sensor is. And then I've got this open source wearable to my phone, to the blockchain, and that's just not happening. But the crypto people are working on mobile clients, and I think once this mobile client becomes secure, I think they will help us liberate the wearable data directly into the blockchain. Whereas the example you'll see tonight is me batching my log files from my open source XYZ accelerometer data and making Merkle trees and storing them on a reference on the blockchain. So let's see that working. Just skip the workflow. So this time, the white is the patient, and is it playing? And the blue is the clinician. And again, very simple private network, two people. Right, so I play the violin. I also play football and skiing, and sometimes I or play badminton. That's sort of number one thing for virus. So I sprained that one, which broken. Cool feature of my laptop has got an extra machine built into it. And so what this is doing here is saying these are smart contracts to machine learning algorithms which are already registered on the blockchain. So putting together my whole X-ray, it's going to my account. It's like I don't want to mark my own homework, so I'm going to get the clinician's account to mine to verify that into the blockchain. It's done. The thing about smart contracts, the ones I'm showing you tonight are just like one standoffs, but what we're working on now is you can call other smart contracts. And this is when things get complicated in the new frontier. So I've delegated Ross permission access to the doctor, and he's given delegated permission to the radiographer, and the radiographer's delegated permission to the machine learning algorithm people, which could be anywhere on the planet. So the doctors looked at the X-ray machine learning algorithm and said it's broken. He thinks it's broken. He confirms a diagnostic, which hits the smart contract. And so when the patient clicks on this, he's calling the. So when we're calling, we don't have to mine, and it's being certified as broken. And of course, the story doesn't stop there. I heal or I don't. Right? So you have the next X-ray coming in to be certified, and this is building up an evidence chain, which over large enough populace we can make assertions whether this technique we chosen to heal my finger was actually the best one, given all the other options pinning. So of course, So the purpose of Dsensor is to give you certainty over the scientific certainty over the outcome. And so right now, if we aggregated all that data in a big enough set, that if we could sample on a random basis across that network and always get the same results, then we could have some reassurance that the algorithm is doing. But I think this is a good example of like the decision stops at the clinician level. Or as I mentioned, I'm a violin player and I wear my wearable. So I'm out in the pub every Tuesday. So I've got that pattern in my history. Now that I've recovered from my finger, does that pattern become back? That's what I ultimately want, isn't it? I don't want to not play my violin anymore if possible, right? So this is the last demo, is taking data from this wearable, which I collect via a laptop, into files. I then take a hash of each file, and I do this Merkle tree process. So I've got 8, and then I have 4, and then I have 2, and then I have the root. And I do that for multiple files. So I've got lots of files, and I do the same for that. And then once I've got that magic number, I put it into a smart contract. And that gives me proof of data. It just says that if I want to run this experiment again on my accelerometer data, I've got cryptographic proof that all these points came from my wearable. This example starts by me registering the sensor onto the blockchain. Time's up. Just about there. So now I've got an identity between me and the sensor and the data and this script at the bottom. Let me get there. It's basically doing the hashing. Just to prove that the data was coming in. So in this example, not only did I hash it, I also saved it to my made safe account. So again, Solidity contract, this storing the hash of that tree and my made safe URL. So that's basically where all my data files from the wearable are stacked. And so I'm just calling this script to do all that work that I described. It's now looking to record it on the blockchain. The blockchain accepts it, and now I've got my address, so I've got them all. Right. So we have got mountains of challenges on IoT healthcare and if anything out with a simple monetary transaction. But the cyberpunks keep on giving. These zero knowledge proofs are also called snarks, and I'm sure there's other things that are going to come along. It's still early days with the financial sphere, so let's get these test projects working on things like living cohort studies as a replacement to clinical trials, and getting some research in mental health and blood pressure. But my sort of moment of eureka, epiphany with Bitcoin was, having looked at it for a second time, was the realization that we started with a bit of history, that 4,000 years ago, the first